G'day students. In the last video we showed you how to solve one-step linear equations. So before we move on and show you how to solve more complicated equations, we still need to do a little bit of thinking about the whole process of solving equations. Now, one thing I mentioned in the last video is the idea of thinking of an equation as a balance. So the left side and the right side are equal to each other. So if you think of that as being like a balance, then you have a balanced equation. And whatever operation you do to one side of the equation, to keep the balance, you have to do it to the other side. Now, another important concept when you're solving equations is the concept of equivalent equations. So if you look at these three equations here on the left, they're considered to be equivalent because they have the same solution. So the simplest of the three equations, in fact, it's what we call the solution, is just y equals 3. But if you put 3 in place of y here, 2 times 3 is 6. 6 equals 6, so that's also the solution to that equation. And if you put 3 in place of y in this equation, 2 times 3 is 6 plus 5 equals 11. That's also the solution to that equation. So the point of all of this is, when you're solving equations, what you should be writing down is a series of equivalent equations. That's your setting out. So there's the original question. After I do my first step, I get this new equivalent equation, which is simpler than that one. And when I do my second step, I get a third equivalent equation, which turns out to be the solution, which is what we're trying to get to. So if you're not writing equivalent equations in your setting out, you're not setting it out correctly. Okay, let's have a look at these three equations. Okay, the simplest of the equivalent equations is m equals 16. Again, that's called the solution because 16 is the answer that makes that true. Looking at this equation, 16 divided 4 equals 4. So that has the same solution as that, so they're equivalent. And the top equation, 16 divided 4 is 4. 4 subtract 3 is 1. So that one also has the solution of m equals 4. So if we start with that equation, whatever we do to solve it, we should get to that equation next and get to that equation third. So if you're not writing equivalent equations in your solution, you're not setting your work out correctly. Let's go ahead and actually work out what the steps are to solve this. So if we're starting with this equation here, I've got to get from that equation to that equation. And the basic concept behind solving equations, the key idea is you do your order of operations in reverse. In fact, you undo the order of operations in reverse. So looking at this equation here, y is multiplied by 2 and 5 is added. So what I have to do first is undo the adding. It's like undressing, like we were talking about taking your shoes off before you take your socks off. So the first step, to both sides of the equation, I subtract 5. And that leaves me with my new equation, 2y equals 6. And that's equivalent to that. They have the same solution. Now I've got to undo multiplying by 2, which is dividing by 2. And I end up with 6 divided by 2, my third equivalent equation, which is also called the solution, y equals 3. Okay, on the right-hand side, see if you can work out for me, please, what are the steps we needed to do to get from that equation to that one to that one. Okay, let's see how you went. Now, the secret is we have to undo the order of operations in reverse. I just call that AMIB. So the first thing we had to do is add 3 to both sides. Think of it as being a balance. Whatever you do to one side, you do to the other side. That gives me m over 4 equals 3 plus 1 equals 4. So that equation has the same solution as that one. And finally, to get from there to there, I had to multiply both sides by 4. And that gives me the final solution, which is m equals 16. So once again, if you're not writing equivalent equations in your solution, you're not setting your work out correctly. Okay, just to finish off this video, it turns out you've got some choices as to what order you undo your questions in, but some orders are much nicer than the others. So let's have a look at how Gareth solves the equation 3y plus 4 equals 22. So Gareth says, oh, I'm going to divide everything through by 3. So he's not really using AMIB. Let's see what happens when he doesn't use the order of operation in reverse. Well, it turns out he's not incorrect. He divides 3y by 3 to get y. 4 divided by 3 is just 4/3. And 22 divided by 3 is 22 over 3. So that's still equivalent to that. But obviously it's much more complicated. So it's actually made the equation look more complicated rather than simpler. The second thing that Gareth did is he said, okay, I'm going to have to undo adding 4/3. So I'll subtract 4/3. So he's done that to both sides. So the operation was minus 4/3. So again, not incorrect, but it's getting a bit messy, and he has to now remember how to subtract fractions. Then he went ahead and said, well, 22 on 3 minus 4 on 3, just subtract the numerators, is 8 on 3. And finally, he simplified that and got the correct answer. So these are all equivalent equations, but he's made it much more complicated than it has to be. If instead he'd used AMIB, as Sarah did, let's see how that works. So Sarah said, well, the first thing I'm going to undo is adding 4. So I'll subtract 4 from both sides, and that leaves just 3y on the left and 18 on the right. And to get rid of the 3, I divide by 3. So there's Gareth's work. He chose to divide everything through by 3 to start with. And there's Sarah's work, where she followed undid the order of operations in reverse and subtracted first. So that's not wrong, but it's unnecessarily complicated. So if you use AMIB, the order of operations in reverse, to solve your equations, you'll find it much easier.